Hi everyone. Today we are going to start with linear equations in two variables. So far, you had learned in class 7th and 8th linear equations in one variable. But now you are going to go with next step, that is in two variables, right? The concept is almost similar, that how you solve the equations, but now we will be having two variables. So it can be xy, it can be mn, it can be pq, but it can be any combination. Nothing is fixed, right? After all, they're variables, right? So let's quickly start to know them. Now, what I have written over here on the screen is ax plus by plus c equals 0. Okay. What you can see are all the alphabets over here. But the variables that we are talking about, x and y, they are the variables. Okay. And this whole form ax plus by plus c equals to 0 is actually the standard form. This is the standard form of any linear equation in two variables, right? So what is a, b, and c? Now, when we talk about a is the coefficient of x. And then when we talk about b, this is coefficient of y. And then lastly, what is c? C is your constant. Okay, I'll just take an example over here. If I write 2x plus 3y plus 5 equals 0. Now, this is an example of a linear equation in two variables, right? Because we have got x and y as our variables. 2 is the coefficient for x, 3 is the coefficient for y, and 5 is the constant. What does that mean? It means that coefficient of x, y, and the constant, that is a, b, and c, they are all the real numbers. They can be negative, they can be positive, they can be decimal, they can be rational, irrational, anything. So they are always real numbers. So I just write down a, b, and c are real numbers. Okay, when we say real numbers, I again repeat, we can have the value of a as negative, positive, b as rational, irrational, and similarly for c also. But the major constraint is that a and b, they both can't be equals to 0. Now, why can't they be equals to 0? Because if they actually turn out to be 0, what will happen? Your x will vanish or your y will disappear, right? In that case, you are not left with linear equation in two variables, right? For example, if I write 2x plus 0y minus 3 equals 0. Now, what does basically it means? It means we have 2x minus 3 equals to 0. So now when we write this 2x minus 3 equals to 0, do you get two variables over here? No, you are getting just one variable. But yes, as per our convenience, we can convert that into two variables if we roll back to where we had started by converting this as 2x plus 0y minus 3 equals 0, right? So this is going to be your linear equations in two variables. Now, when we are talking about the chapter with respect to NCERT, they have already reduced the chapter a lot, right? Earlier, there used to be 2 to 3 exercises, but now they have reduced it to very minimal questions in 2 exercises, and that is very nominal as well. But that doesn't end it over here. Okay. What we are going to do, not in this video alone, but in further videos also, we are going to deal with questions from NCERT, which are going to be based on NCERT. Then we will be dealing with questions from NCERT exemplar and also questions from other books as in R.D. Sharma or R.S. Agarwal, where we will be dealing with extra questions on linear equations in two variables and get to see that how the questions are actually coming in the papers and how do we need to deal with them, right? So now, since we are just getting started with the chapter, as of now, we are going to deal with very easier questions, okay? Now, starting with the first one. The question says, write each of the following equations in the form of ax plus by plus c equals 0 and indicate the values of A, B, and C. This is the question which I have picked up from NCERT. It is based on NCERT. Okay. Some parts may belong to NCERT or may not be. Now, we are having an equation which is 3 equals to x plus y. What we need to do, we need to convert this into the form of ax plus by plus c equals 0. That means the standard form, right? So when we do the standard form, we need to have everything on the same side. Now, what happens over here is many a times children actually think that same side means it has to be only on the left. No, it is not necessary. You can have everything on the right or everything on the left, but the essence is that everything should be together on the same side. Now, since x and y in the first part are on the right, so I'll take 3 also on the right side. Okay, so what does that gives us? That gives us 0 equals 2x plus y minus 3. This is absolutely the standard form because what we have got over here is ax plus by plus c equals 0, right? Now, going over here, they had asked in the question the values of a, b, and c as well, right? So what is a? A is 2, b is 1. Because we cannot see any coefficient with y, that means it's 1, and since y is positive, the coefficient is positive. Now, what is the constant? The constant is -3. So guys, you have to ensure that you carry the sign when you're writing the value of ABC. If something is positive, obviously, you will just write 2, 1, like I have written for A and B. But if something is negative, that negative will come along in the value of whatever A, B, or C. Okay. Now, moving on with the next part. We have 3x minus 8 equals 5y. We can see 5y is on the other side. So I will shift it to the left. So we get 3x minus 8 minus 5y equals 0, right? This is what we get. This is our ax. Okay, sorry, I haven't reduced it in the standard form. Why is it not in the standard form yet? Though everything on the same side. Because we have x, then we have constant, and then we have y, right? So that means we need to shuffle them a bit more. So we get 3x minus 5y minus 8 equals 0. Okay. Now, what is our a? A is 3, b is minus 5, c is minus 8. So in this example, we saw that x was positive 3, b was negative 5, and c is negative 8. Okay. Now, the next one, x equals 4y. We can see only two terms over here, right? But both the terms are having variables. So how do we convert this into standard form? It becomes x minus 4y equals 0. Is it still the standard form? Think. Yes, it is the standard form because we have ax plus by plus c equals 0. And you will see that you will say that you cannot see c over here, right? You cannot see c. So what is going to be the value for a, b, and c in this case? A is 1, b is minus 4, and c is 0. That simply means whatever you cannot see is just 0. Absolutely, right? A is 1, B was negative 4, C is 0. And here we have all these values, right? Now, moving on with the further part, because I have collected further parts so as to give you exposure for all the kind of questions which are being asked to convert in the standard form. So now in the fourth part, we have rational terms. The question says x over 3 minus y over 2 equals 5. Okay. Now, is it the standard form? We just need to bring the constant on the other side, right? That will give us x over 3 minus y over 2 minus 5 equals 0, right? Now, what is a? A is 1 by 3. As I had told in the beginning when we were introducing the chapter, that A, B, and C they can be real numbers. And real means they can be rational as well, right? So yes, this is an example of that, where we are having the value of a and b as rational numbers. A is positive 1 by 3, b is negative half, and c is negative 5. So this is what we get. First the standard form, and then the values of a, b, and c. Okay. Now, the last part of this question, pi x plus y equals 6. Now, pi. This is a very hot favorite question from NCERT actually, because they have just given it to confuse children whether they consider this as a constant or whether they consider it as any other term, right? Pi is there. We had already learned that in the previous chapters, in chapter 1 basically, that pi is basically a irrational number, right? Pi is 22 by 7 or 3.14 and so on. It is non-terminating, non-recurring, right? But the coefficient of x and y can be any real number. That means it can be pi as well. Okay. So first converting this into the standard form gives us pi x plus y minus 6 equals 0. This is the standard form, right? So what is A? A is pi, B is 1, and C is negative 6. So this is what we get, the standard form, and then the corresponding values of A, B, and C, which are pi, positive 1, negative 6, respectively. Okay. This example shows that A, B, or C can be irrational as well. In the previous example, that is 4th, we took rational values. In example 5th, we took irrational value. So we had covered real numbers, that is A, B, C can be real values. And then we saw an example, which was the third one, where constant was absent, but still the value that we got for it becomes 0, right? So we got an exposure to all the kind of questions over here in this question, right? Now, moving on with the next one. The question is similar, write each of the following in the form of ax plus by plus c equals to 0, and then write the values of a, b, and c. The question is absolutely similar, where you need to convert it into the standard form and then write the values of a, b, c. But the parts are different over here, because if you see on the screen, what we have, every part is having just one variable. Yet, we are being asked to convert them into two variables. Okay, so how do we convert that? And as I had told in one of the previous questions, that what you cannot see is just 0. And that is the rule we are going to follow over here also. Okay, so now converting it, it gives me x plus 0y plus 3 equals 0. Why did I write 0y over here? The standard form has to have all the three terms, ax, by, and c. So for that reason, we have to write 0y. Okay, you cannot leave y alone, but you have to write 0y. So now what are going to be the values for a, b, c? A is 1, A is 1, B is 0, and C is 3. The value of, obviously, we are talking about real numbers. When we say real numbers, A, B, C can be 0 as well, right? Yes, when we say x equals to minus 3, it was a linear equation in one variable. But since the question asked to convert it into two variables, we brought y with a coefficient of 0. Okay. Now, similarly, the second part, what we have is y equals to 5. We do not have x over here. So we will represent 0x plus y minus 5 equals 0. This became your standard form. And now A is 0, B is 1, and C is minus 5, right? And the last part on the screen, we have now 3x equals to 2. The question is almost similar to the first part that we had done on top. The only difference is in the first part, x was having a coefficient of 1. Over here, x is having a coefficient of 3. but y is still missing, right? So what do we get? 3x plus 0y minus 2 equals 0, right? Since y was absent, its coefficient become 0, right? Now, a is 3, b is 0, and c is minus 2. This is what we get in this part, right? Now, the next question. So in the first two questions, what we learned? We learned whatever is the scenario, we can still convert it into the standard form, which is ax plus by plus c equals to 0. And then we, in every part of that, we gave the values for a, b, and c respectively, right? Now, moving on with the next one. Show that x equals to 3 and y equals to 2 is a solution of the linear equation 2x plus 3y equals 12, right? So what do we need to do? We need to show that we have got an equation in two variables, 2x plus 3y equals 12, but now we need to show that x equals to 3 and y equals to 2 is a solution of it. So when we talk about the solutions, what actually we need to do? We just need to plug in the values, corresponding values of x and y in the given equation and check, are we actually getting an answer equal to the right hand side or not? Okay, let's see how to do it. Since x equals to 3 and y equals to 2, we will substitute them in the equation 2x plus 3y equals 12, right? So now substituting them, 2 into 3, x was 3, right? So instead of x, I replace that with 3. Now, 3 times y is 2. So replacing y with 2 equals 12. Now, the right hand side is already fixed. It's a constant, 12. So what we are going to do? We are going to solve the left hand side in this case. So 2 times 3 is 6 and then 3 times 2 is again 6. So what do we get? 6 plus 6 is 12 and we got both sides equal. Whenever we get both sides equal, that means the given values of x and y are the solutions of the respective linear equation, right? Since now we have already used since over here, just a moment. LHS equals RHS, right? Now, as we got both sides equal, x equals to 3 and y equals to 2 is a solution of linear equation 2x plus 3y equals 12. So this is how we need to conclude, though it's just a 2-marker question where we were given a set of values for x and y and we were supposed to show whether it's a solution or not. But still, in the end, we are supposed to conclude in our own words if it is a solution or not. Okay. So be careful. You just need to plug in the values and solve it. And that's all. We don't have to do with anything else in that question. Okay. Now, moving on with the next one. Find 6 different solutions of the equation x plus 2y equals 6. 6 different solutions. Okay. So now what they are saying, can a linear equation in two variables have so many solutions? Yes, it can have infinite solutions. One linear equation in two variables can have infinite solutions, right? And now we will see how actually it can have so many solutions. What we are going to do over here, we are going to tabulate it. That means we are going to create a table of values and see that how the values actually, how we give so many solutions to this given equation, right? So first let's create a table. Okay. What I have done, I have created 2 rows and 7 columns. Okay. Because in the first column, I'm going to write X and Y. And then they had asked for the 6 values. So for that, I have left 6 blocks. Right. Now, in this table, what we are going to do, we are going to start putting in any value, any random value for X. You can do that with Y also. I always like to put in the value of X and then find the value of Y. So let's see how do we do it. I'm starting with 0. You can take any positive value, you can take any negative value, and you can take 0 also. If you want to take fractions, you can do that. Even decimals are absolutely fine. But the thing is, why to bother with fractions and decimals? We should be keeping our calculations simpler. Okay. Now, X is 0. So in the first case, though we are not supposed to show this working, as this portion, these kind of portions are not very heavy weightage, but I am showing all the calculations to you so that you understand how to actually do them, right? Now, when X is 0, that means I'm going to replace X with 0 in the equation. So it was X plus 2Y. It becomes now 0 plus 2Y equals to 6. We are left with 2y equals to 6. That means y equals 6 by 2, which is 3. Okay. So I wrote the value of 3 over here. So what did we get? We got the first set of value, that is first solution for the given equation x plus 2y equals to 6, and the solution is 0, 3. Okay. Now the second one. I'll take the value of x as 1 over here. Now, when it is 1, I get 1 plus 2y equals 6. That means 2y equals 6 minus 1, 2y equals 5, and y equals 5 by 2. That is 2.5. So see over here, though I had taken an integer value for x, but the value of y that I got after solving is a decimal. So that's absolutely fine. We can have various kind of combinations because though x was integer, but y we got as a decimal, or you can convert that into a rational also, which was 5 by 2. So that is absolutely okay. Okay. Now, the next value I will take for x is minus 1, right? As I said, we can have any kind of value, negative, positive, 0, whatever you want. So solving for that, we get minus 1 plus 2y equals 6, right? So we are having 2y equals 6 plus 1. Solving it on the next slide. So we have 2y equals 7 and y comes out to be 7 by 2, that is 3.5. Right? Again, I took a negative integer for x, but for y, we have got 3.5. So the first 3 solutions that I had done over here, I showed you all the working, right? But now the next set of 3 values that I will take for x, I will not show the working, but we will do the calculations mentally. Okay. Now, if I take x as 2, so what happens? We'll get 2 plus 2y equals 6. Now we'll take that 2 to the other side. So 2y becomes 6 minus 2, that is 4. 2y equals to 4. And now y equals 4 divided by 2, that is 2. So over here, the values for x and y are same. X was 2 and y is also 2. It is also absolutely acceptable and it is perfect set of values, a perfect solution for a given any equation, not just for this, but any equation. That means the values of x and y can be same also. That is a perfect solution, right? Now, let's take another value for x. Okay, let's take a rational number over here. Okay, let's take half. As I have been telling that we can have any kind of values. Okay, so now if I take x as half over here, let me show you the calculations. So this is the fifth set of value. We get half plus 2y equals 6. So 2y equals 6 minus half. Took the whole fraction to the other side. So it turned negative. Now, taking up LCM on the right gives me 12 minus 1 by 2. That is 11 by 2. So 2y equals 11 by 2 into 1 by 2. That is 11 by 4. Now, 11 by 4, if you want to leave this as it is, that is also fine because we are just creating solutions. We are not doing any plotting on the graph. Yes, when we talk about this chapter will also include graphs, which we have learned in coordinate geometry, right? But as of now, we just wanted to have the solutions. So we can leave that values absolutely perfectly in this case as rational numbers also. We took x as 1 by 2 and we got y also as 11 by 4. Both are rational. Okay. Now, let's take x as 3. Now, let's do the calculations mentally again. So when x is 3, we get 3 plus 2y equals 6. Okay. 3 taken to the other side gives us 2y equals to 6 minus 3. That means 2y equals to 3. So therefore, y comes out to be 3 divided by 2. That is 1.5. Now, what I have done over here, I randomly took some values, that is 0, 1, -1, 2, half, 3 for x. And with each value, we got a corresponding value of y, and hence each of the following set actually becomes a solution. This is one solution, second, third, fourth, fifth, and sixth. So these are 6 solutions by me for this given equation. Now, when we are talking about such questions, actually, these are quite open-ended questions. Open-ended in the sense that I got these values. You may take some other set of values for x and you will get different answers for y. It is not necessary that whatever answers I have got, you also need to have the same answers. They can be different. So it's absolutely fine that when you discuss amongst your friends and the answers are not same, no need to worry. We can have different answers in these questions. Okay. Now, that's all with respect to this video. But before closing, what we had learned, we got introduced to the standard form of a linear equation in 2 variables. Then we learned how actually we can convert any kind of an equation, whether it was initially given with 1 variable or 2 variables, but still we learned how to convert them into the standard form and determine the values of a, b, and c. And after that, in the next set of questions, we learned that how we found the solutions of an equation, or if a solution is given, then how actually to substitute and verify whether it is a solution or not. So do practice on the same questions or even different questions and gain confidence before proceeding to the next set of questions from this chapter. Happy learning!